Hi students, welcome back to the channel. In this lecture series, we are going to cover inter-process communication, that is one of the most important topic in operating system. This topic will definitely come in your upcoming college or university level examination. So if you forgot to watch previous 9 lectures, you can check the description box. I have already added the link there. So let's start with the introduction of what is the inter-process communication. So as you can see here, interprocess communication is the mechanism provided by operating system that allow processes to communicate with each other. In simple terms, we can say that IPC, that means inter-process communication, is used for exchanging the data between multiple threads. Exchanging the data between multiple threads in one or more process or programs. Also, we can say that the processes may be running on single or multiple computers connected by a network. So this is the important definition of inter-process communication. Also, this communication could involve a process letting another process know that some event has occurred or the transferring of data from one process to another. In simple terms, we can say IPC is the only communication process that allow a process to know that some event is going to occur in the operating system. Other than this, you should also know that IPC is nothing but it is a set of programming interface. It is a set of programming interface which allow a computer programmer to coordinate the activities among various program processes which can run concurrently in an operating system. So IPC plays a very important role in every operating system. So also students, one official definition of IPC is that it is used for exchanging useful information. Used for exchanging useful information between numerous threads in one or more processes. One or more processes or programs in a computer. So this is the definition of inter-process communication. I hope students everything is clear till now. Let's say in my operating system, this is my CPU that helps us to complete or fulfill the request given by the processes. And here we have multiple processes. Okay, so all these processes are simultaneously requesting for the CPU to run any task. So IPC helps all these processes to communicate with each other related to the fulfillment of their requirement. Okay, so now we have synchronization in inter-process communication. So synchronization means what? Synchronization is a very necessary part of IPC. It is either provided by inter-process control mechanism or it can be handled by communicating processes. Some methods of using synchronization in IPC include mutual exclusion, semaphores, barrier, and spine lock. All these statements are very, very important, right, students? So, we will start with the first point, that is the mutual exclusion. So, what is the meaning of mutual exclusion? It is students, before moving to mutual exclusion, I would like to tell you about two important statements that you will uh, listen in upcoming lectures. So first statement we have is semaphores. Okay, so what is the meaning of semaphores? Semaphores are nothing but it is signaling mechanism technique. This operating system method either allow or disallow access to the resources which depends on how it is set up. And another important term is signals. So signal plays an important role in case of inter-process communication. So signal is a method to communicate between multiple processes by way of signaling. With the help of signals, if two processes share data, if two processes are going to communicate with each other, then the term used here is signaling. The source process is what? The process that is sharing the information with another process. The source process will send a signal which is recognized by number. So all these processes, all these signals are given some numbers, and the destination process will handle the signal by identifying that particular number. So this is how you can make use of, you can communicate, processes can communicate with the help of signals. Okay, so I hope students everything is clear till now. Next point we have is synchronization in interprocess communication. So here we have first point, that is mutual exclusion. So mutual exclusion requires that only one process thread can enter the critical section. It says that only one process thread can enter the critical section at a time, and this is useful for synchronization. This is very useful for the process synchronization. Okay, this is useful for synchronization and also prevents race condition, and also prevents race conditions. So these statements are important for your examination. So many times these statements are asked as it is. So this is the mutual exclusion. In case of mutual exclusion, all the processes should mutually understand their requirement and send their requirement request to CPU or any other resource. So it will, if every process use mutual exclusion process, then there will be no deadlock in your system. So what is the meaning of deadlock, what is the meaning of critical section, and what is the meaning of race condition? All these things are very important that we are going to cover in our next video. Till then you should know the basic definition only. Next is semaphore. So semaphore is a variable that controls the access to a common resource. Okay, let's say this is a common resource CPU. Semaphore is what? It is a variable that control the access to a common resource by multiple computer processes. The two types of semaphores are there. First is binary semaphore and another we have is counting semaphore. So this particular topic is a very important topic. We will cover this separate, we will cover this topic in a separate session. Okay, so semaphore you should know is a variable that controls access to a common resource by the multiple processes in our system. Next we have is barrier. So the barrier does not allow individual processes to proceed until all the processes reach it. Many parallel languages and collective routine impose the barriers. Other than this, we have spine lock. So spine lock is what? It is a type of lock, and the processes trying to acquire this lock wait in a loop while checking if the lock is available or not. So this is known as busy waiting. Spine lock is also known as busy waiting in operating system because the process is not doing any useful operation. Because here the process is not doing any useful operation even though it is active. So that's why the interprocess communication uses synchronization. So all these are the four important roles provided by IPC for the synchronization of the processes. So students, I hope everything is clear to you till now. If you have any doubt, you can comment below. I will definitely help you. Okay, so here let's just revise it once more. The interprocess communication. Let's take an example here. In interprocess communication, we have multiple processes. Okay, this explanation will help you summarize the lecture. Okay, in interprocess communication, we have multiple processes. All these processes are waiting for or wanting wanted the resource, that is the common resource, let's say CPU. You can take any example. This is the process 1, process P2, P3 and P4. Okay, so all these processes are requesting for this particular resource. So whenever, let's say, process P1 is requesting and resource is busy with process P3, if P1 is not responding fast, if P1 does not want to wait, then there will be a deadlock in the system. And to avoid the deadlock, or to avoid the locking of the entire network of the system, we can use the synchronization. So these four statements are also very, very important. So thank you so much for watching this video, and in next video we will cover the approaches to IPC, that include pipes, shared memory, message queue, direct communication, indirect communication, message passing and FIFO. FIFO stands for first in, first out. So thanks for